I've talked a lot about us writing many small instructions to the computer. Add one number to another number, or display the word hello on the screen. When we actually write source code, we call each of these a statement. That's a few words or symbols arranged to make one self-contained specific instruction. A statement does something. It's code that has an effect in your program. And that means a statement must be complete. It must make sense in the same way that a written or spoken sentence must make sense. If I said, change the color of, you'd wonder, change the color of what exactly? Or add 99 to, or print, or move. You'd understand these words fine, but you'd recognize these as being incomplete. So there's a difference between just knowing words of a programming language and writing a statement that uses those words. Now, usually statements are just a few words. They'll often fit easily on a single line in your source code to say what is being done and what is it being done to. As examples, change the color of the background to light blue. Add 99 to whatever the current score is. Print the current document to where? Well, the default printer. Or move what? Move the spaceship graphic. How far? 5 pixels. Which direction? To the right. Again, specific, small, self-contained instructions. Now, occasionally, a statement can be just one word, the same way that you can have a complete sentence in English of just one word, although that's usually in response to something. When are we meeting? Tomorrow. What's your favorite color? Red. When are you leaving? Now. For a computer program, the equivalent one-word statement might be, what do we do when we finish converting this file? Quit. What happens when the user presses the wrong key? Beep. But most of the time, we need a few words, a few pieces to our statements. So these are the kinds of statements we can write. But as you can probably tell, I'm not writing them here using any particular programming language, just this informal description. So let's just take one to add 99 to the current score and see this written as a statement in a few different programming languages. Now, these all assume that whatever language I'm using, maybe we're writing a simple game, we've decided we want to keep track of and change a number that we'll call score. Just as someone might scribble a score on a chalkboard and change that score while a game is being played. So let's begin with an older language. In the programming language COBOL, this statement could be written as add 99 to score. In AppleScript, a different language, we'd say set score to score, whatever it is right now, plus 99. Same intention, same result, but a different syntax to do it. In a lot of other programming languages, adding 99 to score is written as score equals score plus 99. Sidebar. This format, this syntax, is a very, very common way of doing it, and it can confuse people new to programming who think that it looks like one of these algebraic equations they have to figure out somehow. They have flashbacks to high school and think, oh, is this one of those things where if x is 99 and b over c is 52, then how many apples fit on a train going to Chicago? No, it's nothing like that. This is our statement. This is our instruction. We're not asking anything. We are telling the computer to do something here. The equal sign in this statement is not a question. It is a command. You can think of this equal sign here as meaning is now made equal to. So when we execute this one statement, score is now equal to score, whatever it was previously, plus 99. And in a lot of other languages, the syntax is almost identical except we need to add a semicolon at the end. You see, no matter what language, it's very common to write every separate statement on a separate line in your source code file. Now, sometimes a statement can be split across multiple lines. Usually that's not required. It just makes things easier to read. But in many languages, having them on separate lines is not enough. You must also explicitly end each statement with a special character, one that says this statement is now complete, like having a period or full stop at the end of a sentence in English. It's what can tell the compiler this statement is finished, go ahead and convert it into machine code. The most common character to end a statement is the semicolon. You'll find this used in C and in many languages based on or influenced by C, like Java, C#, PHP, Objective-C, C++. It is very common to see this semicolon. Whereas in COBOL, or at least some versions of COBOL, it's the same idea, but there you would end a statement with a period. In other languages, Ruby, Python, Swift, for example, You don't need a special character. You just end each statement with a line break. You don't need a period. You don't need a semicolon. Just by having separate lines, each one is treated as a complete statement. And again, folks, right now, don't worry about memorizing what language exactly does what. That's not important here. We're working on recognizing what all these languages need to do. They might do them differently. They might have a slightly different syntax, but they all do them. Because even without memorizing any of the syntax, you start to recognize that a lot of this is shared across languages. If you learn how to add one number to another number in Ruby, it's going to be the same in Python and the same in Swift and almost the same in C and Java and PHP and many others. So let's move on. I'm going to talk for a moment about the benefits of writing our instructions so that they're not targeted at one specific programming language. And then we're going to move on to the syntax that you don't see, the invisibles, the tabs, the blank lines, the spaces, the white space of a programming language.